evening to all professors for fourth day, first session. Today, very interesting topic. We are going to see that transportation energy for sustainable future. The topic is going to cover by Dr. K. Karupasamy. He is going to speak about this topic, transport energy for sustainable future. Dr. K. Karupasamy, Assistant Professor, Senior Grade, Department of Mechanical Engineering, Anna University, Regional Campus, Tirunelveli. So nowadays, the transport is very important aspects for everyone. It is very most important for everyone. So starting with bullock cart, then steam engine, then conventional engines like petrol, diesel, and then again parallelly they have started electrical vehicle also once upon a beginning. Then again for that all fuels for steam engines, external combustion engines, then internal combustion engines. For external combustion, steam engines nowadays not at all used, old one. For that, coal is used. Everyone knows that. Then slowly they have moved to internal combustion engines. For that, petrol, diesel, Rudolph diesel, and auto people have found that, discovered that auto and Rudolph diesel. Then parallelly they tried electric vehicle, but at the time it's not boomed. But nowadays it's boomed to electrical vehicle and hydrogen-based vehicle. So because of pollution, we are everyone talk about pollution nowadays, because the pollution is particularly greenhouse emission, CO2. So study of Dr. S. Murugan clearly told about CO2 emission, CO capture, storage. So CO, okay. So today our Karupasamy is going to talk about these only conventional fuels, then renewable fuels, how pollutants are created from that, how to avoid that, and then he is going to touch upon hydrogen fuel also. So welcome you, Dr. K. Karupasamy sir, for this session. Small introduction, detailed introduction about Dr. K. Karupasamy by Mr. Vinod from Civil Department. I call Mr. Vinod. Please give a brief introduction about Dr. K. Karupasamy.
So good evening to all. First of all, thank you for giving this opportunity for deliver the speaker introduction for this Atal Faculty Development Program. Today's speaker, Dr. K. Karupasamy, Assistant Professor, Senior Grade in Mechanical Engineering, Anna University Regional Campus, Tirunelveli. He done UG Mechanical Engineering in Madurai Kamarajar University in 1997. Then he done PG Internal Combustion Engineering in Anna University, Chennai, 1999. Then he completed doctorate under the domain of Mechanical Engineering in Anna University, Chennai, 2014. For his professional experience, he worked as a lecturer in SACS Engineering College from 1999 to 2005. Then he served as an assistant professor in Sanmonathan Engineering College from the period of 2005 to 7. Then also he worked as a Sudarshan Engineering College under assistant professor in 2007 to 9. Currently, he is working in Anna University Regional Campus, Tirunelveli from 2009 to till date. He got additional responsibility for serving as a zonal officer in Tirunelveli from 2023. Next, he served as head of the department from 2020 to 2024. Then also he was a nodal officer for Anna University theory exam at Regional Center of Anna University held on November-December 2015 and January 2016. He also served as a chief superintendent for Anna University theory exam at Regional Center of Anna University held on the same year. He was the camp officer for the central valuation in 2017 and 18. He also served as a chairman and vice chairman for the central valuation. He was the member for affiliation of inspection for all the self-engineering college. He served as a purchase committee member in Anna University of Technology, Tirunelveli. Under his guidance of research, PhD completed student 70, ongoing 2, doctorate completed student 3, ongoing 3. He published the paper of International Conference 19, National Journals 2, then International Journals 19, then National Conference 15. He delivered a guest lecture on various colleges all over Tamil Nadu, like Infant Jesus College of Engineering and Technology, National College of Engineering, Dr. Sivanthi Adityanar College of Engineering. Then He delivered expert lecturer in Government College of Engineering, Tirunelveli. Then he organizing a secretary for the National Conference on Advances in Mechanical Engineering held at Anna University Regional Center on 2015. He was the coordinator for Technofair 2016 held at District Science Center, Tirunelveli from 3 to 5 March 2016, jointly organized by District Science Center and Anna University Tirunelveli region. He was the coordinator for National Conference on Emerging Technology held at Anna University of Technology, Tirunelveli on 2011. He was qualified in GATE 1996 and 2001. He received MHRD scholarship for pursuing MA degree at College of Engineering, Gindi, Anna University, Chennai. We are very blessed to get this type of person for our FTP program. We are eagerly waiting for our session, sir. Thank you so once again. Thank you so much for giving this opportunity for deliver this kind of wonderful person for this Atal FTP. Thank you so much. The session is over to you, sir.
Thank you, sir. Thank you. I will start.
Sir, shall I take group photos, sir?
Yes.
Now itself.
Good evening to all. I'm going to present in the topic of transportation energy for sustainable future. So my presentation overview is introduction, conventional fuels, then alternative fuels, then alternative vehicle technology, then conclusions. So these are the topics. In the conventional fuel, I have to discuss about the petrol and diesel. In alternative fuels, I have to discuss about the alcohol, biodiesel, hydrogen, natural gas, and LPG. In the alternative vehicle technology,
Or go to the
Yes,
sir.
And the slide also not moving.
Or come to the slideshow and okay, so no issue, sir. The top side will check, sir. Top side will check, sir.
So there's a introduction part. Almost in the growing due to the climate changes has pushed the adaptation of sustainable transportation energy. So in this regard, electric vehicles are the feasible solutions. Electric vehicle is the only feasible solutions. However, the commercialization of electric vehicle is very difficult. So the on-road electric vehicles faces multiple challenges such as adequate number of charging stations, availability, and charging time, and range anxiety. So in order to overcome these issues, fuel cell vehicles also come. In order to overcome the issues, we have to integrate. So we have to integrate the renewable energies, and also the government have to take government has to take more plans to give priority to government has to give priority for producing energy from the various sources, renewable energy sources, renewable energy sources, and also adapting a number of and also generate more service stations, more charging stations similar to petrol diesel stations. They have to generate. They have to build more number of more infrastructure for implementing this e-vehicle technology in our country. Okay, so these are the introduction part. For transportation of goods, material, and people, we are using vehicles. So because of that, for transportation from industries as well as some urban areas to people moving from some places, so everybody is using vehicles nowadays. So because of that, we are getting more pollutions, CO2, HC, NOx, and particulate matter and soot. So these are the vehicle past trends and projection of vehicles populations. So in the year 2025, so we are around three-wheelers. We are going to have 250 millions, and around heavy vehicles 9.1 millions, and 12.5 millions for cars and SUVs. So these are the vehicle population increases. From 2015 to 2025, the vehicle population will increases. Because of that, the emissions also increases. CO2 emissions also increases in some of the countries. Some of the countries are listed in this graph. That is United States, Canada. The vehicle populations projected from the year 2025, 15 to 25, they are the three-wheelers are increasing. That is 246 millions, and for two-wheelers is around 174 millions, and other heavy vehicles cars and SUVs are around 14.16. The vehicle populations are increases. Similarly, the emissions also, CO2 emissions also increases. Some of the selected countries are mentioned in this graph. So India's petroleum statistics for the current consumption for this year 2023-24 is 234 million tons, metric tons. So indigenous, our production is around 50. So we are importing maximum of 180 metric ton. So the cost of import is around 8 lakh crores we are spending. So the for petroleum, we are petroleum used car in the transport sector is around 80%. The annual consumption growth is 10% in the other sectors. So the pollutions from the conventional fuels, there are the major pollutions from the conventional fuels are diesel. If you use diesel as a fuel, we are getting this smoke, soot, oxides of nitrogen, carbon monoxide, and unburned hydrocarbons are these are the emissions away coming from the diesel vehicles. But oxides of nitrogen and soot are the major problems. So these are higher amount releasing and compared to gasolines. Okay. If you go for gasolines, you have carbon monoxide, unburned hydrocarbons, and oxides of nitrogen. So here the oxides of nitrogen is the major problem for gasoline vehicles. So these are the emissions we are facing today in India. So now we go into the alternative fuel technology. So in the alternative fuel technology, either we can use the alternative fuel as a sole fuel or neat fuel or pure fuel or state. So this is or we can modify the engine to suit the fuel, or modify the fuel to suit the engines, or we can blend the fuel. These are the methods of using alternative fuels in engines. Biodiesel. Normally, biodiesel is a monoalkyl esters of strong fatty acids derived from the renewable feedstock. The advantages of biodiesels are environmental friendly, biodegradable, non-toxic, CO2 balance, and utilization of waste. We are utilizing the wastelands, and employment opportunities are there. And these are the raw materials for biodiesel production. Some of the edible oils are there: sunflower, palm oil, sesame, rice bran, and peanut and groundnut and soya beans. And non-edible oils are rubber seed, rapeseed, cotton seed, and Jadropha, Pungamia, linseed, and castors. So most of the research is depends on the non-edible oils, because these oils are available in plenty in India. So these are the availability of vegetable oil in India in 2012 statistics. Some of the statistics: cotton seed oil around production is around 11.9 lakh ton, and rice bran oil around 8.5 ton. And these are the techniques for converting vegetable oil into fuels. So preheating the vegetable oil having a higher viscosity. So we have to preheat the engines, and so we have to preheat the vegetable oils, and then we have to inject into the fuel, inject into the engine cylinder, diesel engines, and blending with the diesel as well as alcohol. We can reduce the viscosity, and we can use as a fuel for engines. And micro emulsification process. So we have to add certain emulsifier to reduce the viscosity of the vegetable oils. And thermal cracking. So we have to crack the vegetable oils, and then we have to utilize it. Then transesterification. Transesterification is the process of converting a triglyceride into monoglyceride. So triglyceride into monoglyceride, that is monoethyl esters. Okay. Then the use of adiabatic combustion chamber engines, and using additives and dual fueling with the gaseous and liquid fuels. So transesterifications is to make the glycerol esters into alkyl esters in the presence of catalyst. So NaOH or NaOH catalyst preferably using for biodiesel productions. NaOH or KOH. These are the catalysts. Methanol or ethanol, we are using this alcohol as methanol or ethanol, and NaOH catalyst we are using. NaOH or KOH catalyst using. Finally, the alcohol esters, biodiesels, and the pure glycerin are obtained after the reactions. So there's a triglyceride plus 3 mole of catalyst that produces methyl esters. So this is a setup a facility. This is a small batch reactor for producing biodiesels. So here is a batch reactor. It's a 3-way conical flask, round bottom flask, So we are mixing the oil and as well as vegetable oil, vegetables. So oil as well, vegetable oil as well as methanol. 1:3 ratio. 1 mole of 1 mole of vegetable oil plus 3 mole of ethanol. And we are with the magnetic stirrer, we are heating the oil up to 65 degree, and then we are giving stirring with the proper stirring, the catalyst as well as the vegetable oil mixes, and reaction after reaction, we after 3 hours reaction time, we are getting a biodiesel as well as glycerin. So these are the setup used for testing the biodiesel fuels. These are variable compressor ratio engines. We are, with the different blends, we can test the engines. Measure the fuel consumptions as well as brake thermal efficiency and other engine parameters, brake thermal efficiency, total fuel consumption, then specific fuel consumptions and emissions. So emissions, we are using emissions as well as we have to measure the pressure and temperature inside the combustion chambers by using a combustion analyzer. We can, this is a combustion analyzer, we can find out the P theta diagram. So with the help of the combustion P theta analyzer, we can estimate, we can we can determine the pressure crank angle diagram, heat release rate, other things. Okay. So these are the analyzer smoke, AVL smoke gas analyzer for measuring the exhaust gas emissions, as well as the smoke meter for measuring the smoke intensity. So these are the performance parameters done. After that, we are getting the emissions. When you use biodiesel as a fuel, the emissions are comparatively reduces when for 100% as well as B20 fuel, because of the biodiesel itself contains excess oxygens. That is one of the reasons we go for algal fuel. So naturally algal is obtained from natural sources as well as manufacturing methods. Methanol and ethanol are the algal we are using. So some of the advantages of this algal fuels are obtained from number of sources, both natural as well as manufactured. This is a high octane fuel. So anti-knocking number is anti-knocking index over 100. It produces over overall emission, less overall emissions compared to gasoline. It has a high latent heat of appreciation, which results in cooler intake process. Because of that, we are getting less NOx emissions. And algals have a sulfur content, low sulfur content in the fuels. So disadvantages of algals have low energy content. So the calorific value of the algal is very low when compared to the diesel and petrol. The combustion of algal produces more aldehyde. So algal is much corrosive than gasolines. It has a poor cold weather starting characteristics. Algal almost invisible. So it is dangerous for when handling the fuels. So these are the properties of different fuels: gasoline, diesel, and ethanol and methanol. So in the calorific value, you can see that the calorific value of the fuel is very methanol and ethanol is very less. That is methanol is 27, and for ethanol is 20 when compared to the for gasoline we have 44 kilojoules, and this is for 43 kilojoules, 44 megajoules, and this is for 43 megajoules, and this is for 27 only. And these are the stoichiometric air fuel ratio. That is for gasoline 14.9 and diesel 14.5, and ethanol and methanol we have ethanol and methanol is carbon to hydrogen ratio is very less. Therefore, we have a lesser amount of oxygen is required for burning for complete combustion. So these are the boiling point, and these are latent heat of appreciation and self-ignition temperature and CT numbers. So you can see that the CT number is very low for ethanol and methanol when compared to the gasolines and diesels. But octane number is very higher. So octane number is 101 and 100. So it is algal is a good SI engine fuel. So ethanol in SI engines, either it can use as a blend fuel or solutions, or E85 or M85. E85 means 85% ethanol plus 15% petrol. M85 means methanol 85% and 15% we have gasoline. So this flexible fuel vehicles are designed to operate algal. Either we are designed to operate on algal or petrol on any mixture of the two. Nearly 4 million flexible fuel vehicles have been manufactured in the US since 1996. So these are the prominent flexible fuel vehicle manufacturers: General Motors, Ford, Daimler, Chrysler, Honda, Mitsubishi, Mazda, Nissan, Hyundai. So ethanol in CA engines These are the techniques. We are using ethanol as a fuel in CA engines, alcohol diesel fuel solutions, alcohol diesel emulsion, alcohol fumigations, dual fuel injection, surface ignition of alcohol, spark ignition of alcohols, then alcohol containing ignition improving additives. So these are the various methods of using alcohol in CA engines. Then property of the fuel is ethanol is given. There is self-ignition number is 360 and air fuel is 9:1 and CT number is 9 and have a latent heat of 1.0175 megajoules. The methods of using ethanol in CA engine is solution. First we have to use for a solution method. So up to 20% replacement is possible in this method. So here phase separation is happening. So when you mix diesel along with the diesel 20% of alcohol, phase separation problem is also happening. Okay. The emulsification problem, we have to add this in order to avoid the phase separation problem. So we have to add certain emulsifier that mixes that fuel will be in collider conditions for certain duration. Stable emulsion is also there. The unstable emulsion is also there. The cost of the emulsifier is higher. So here also replacement is possible up to 40% of diesel only. 40% of alcohol is used in this method. So next is fumigation. So it's one of the method for using alcohol in diesel engines. So here carpet is provided. Additional carpet is fitted in, for operating the ethanol in the intake stream. Then dual injections. That is direct injection of ethanol into the cylinder. So pilot injection of diesel is up to 90% replacement is possible. 90% ethanol and 10% of diesel is injected at the end of the ignition, at the end of compression for igniting the alcohol fuels. So these are the ignition improvers to increase the CT number. That is a dimethyl ether are used. So the replacement up to 100% is possible with this method. So then for spark ignition, there is a spark ignition is one of the method. Instead of we are providing a spark plug in the cylinder head. Apart from the injectors, we have to provide a spark plug. Additional provision of spark plug. With the help of it, we can ignite. We can do it 100% replacement, and also we have to provide ceramic coating inside the combustion chambers to maintain the combustion chambers becomes hot. So this is a spark resistance. We are here. We can see that we are this is spark plug and this is the injector. Okay. So this additional spark plug is provided. Then surface ignitions methods of using ethanol in CA engines. Surface ignition. Surface ignition is another method. We are in this method also. We are providing a we are with the help of the glow plug. So glow plug is similar to spark plug. The glow plug is inserted in the cylinder head. So glow plug is threaded into the cylinder head that maintains that absorbs heat and maintains when the fuel is injected, when the alcohol is injected, it gets the heat from the glow plug and it's vaporized. So these are the oxides of nitrogen. Oxides of nitrogen for diethyl ether is very low because of high latent heat of vaporization. The oxides of nitrogen is lesser. The smoke is also less because the carbon to hydrogen ratio is very less when we go for alcohol. When we use alcohol, therefore the smoke is also less. Alcohol have a lesser carbon atoms, hence the low pollution that requires special coating for that, like ceramic coatings. And a phase separation problem is if blended and replaces lead. And the comparison of fuel properties to methanol, ethanol, and gasoline and E85. So these are the properties. These fuels are compared. Then advantages of ethanol as a fuel. This is a high octane number enables higher compression ratios, hence higher thermal efficiency. They enable lean burn operations, better combustions, lower CO and particulate emissions. Higher latent heat of vaporization increases the engine overall efficiency due to the reduced heat losses and less tendency for knocking. Then hydrogen fuels. So hydrogen, when we use hydrogen as a fuel for engines, so a number of automobile manufacturers have built with a prototype or modified engines which operates on hydrogen as a fuel. Hydrogen, there is a low emissions. Only hydrogen, there is no carbon content. Only only there is no CO and HC emissions or emissions from the when we use hydrogen as a fuel. So most of the exhaust would be H2O or N2 or NOx. So fuel availability, there are number of different ways for making hydrogens. That is including electrolysis of water. Then fuel leakage to environment is not a pollutant. High energy content per volume when stored as a liquid. These are disadvantages. Requirement of heavy and bulky fuel storage both in vehicle as well as in service stations. There is cryogenic liquid. Or it is the liquid hydrogen is stored in the form of cryogenic or liquid or in the compressed gas format only. So difficult to refill and the possibility of detonations, poor engine volumetric efficiency, and fuel cost will be higher at present day technologies and availability. Higher NOx emission because of higher flame temperatures. So these are one of the methods. These in all the fuels you can see that the primary energies, that coal, natural gases, biogas, biomass, solar, photovoltaic, wind, hydropower. So all the energies you can see that the coal with the gasifications, natural gas steam reforming, and biogas, SRM, biomass gasification. So with the help of these technologies, we can convert these fuels into hydrogen. We can convert this fuel into hydrogen. So these hydrogen is stored as either in the form of liquid. We have to handle this hydrogen in the liquefaction form or compression form or in the metal gated form. So these renewable energies are used for electrolysis purpose, electrolysis of water. So electrolysis of water, with the help of this, we can get a hydrogen. So these hydrogens are handled by liquefaction or other methods. Either you can transport by pipelines or trucks, storage and refilling utilizations, that is storage of liquid hydrogen or compressed hydrogen or hydrates, okay, and refilling and transport. So methods of hydrogen storage already there's compressed hydrogen. So hydrogen is compressed at a high pressure of around 700 bar, and it is stored in high strength composite tanks. And this is the most commonly method for storing hydrogens in vehicles, and it offers balance between the storage density and safety. And liquid hydrogen is cooled extremely low temperature of minus 253 dC to convert into a liquid form. This increases its energy density and allowing more hydrogens to be stored in the given volume. And metal hydrates, hydrogen can be stored in a solid form by chemically binding with the metals, magnesium, sodium, et al. So this method allows safe and more compact storage, but requires significant heat to release the hydrogen when needed. Chemical storage. So hydrogen can be stored within the liquid organic compounds such as methanol, ammonia, which releases hydrogen through the chemical reactions when needed. So these are the technologies for storing hydrogens. That is compressed gas technologies and liquid hydrogen, metal hydrates with the volumetric density, gravimetric density and volumetric efficient density. Then can be used in SI engines by manifold injections or by direct introduction of hydrogen into the cylinders or by supplementing gasolines. So this liquid hydrogen. So we are liquid hydrogen. This is a small chamber, and then we can directly inject the hydrogen into the this hydrogen injector. So these are actual engines. It's internal combustion engines. This is a spark plug. So we are injecting the liquid hydrogens into the cylinders, into the combustion chambers. Petroleum gas, LPG. Next, previously we discussed about hydrogen. Next, LPG. So LPG is normally a combination of propane and butane. Either 50-50 or 60-40. Propane 60%, 40% is butane. These combinations will be there. Okay, LPG contains lesser carbon than petrol. So LPG powered vehicle produces 50% less emissions when compared to carbon monoxide per kilometers, though only slight less nitrogen compounds. Therefore, emission is much reduced by the use of LPG. LPG mixes with air at all temperatures. In multiple cylinder engines, the uniform mixture can be supplied to all cylinders. Since the fuel is in the form of vapor, there is no crankcase dilutions. Automobile engines can use propanes. LPG has a high anti-knock characteristics. So it is about 80% of the heat energy is about 80% of the gasoline. But if you have a higher octane number, so running on LPG translates into a cost saving of 50%. The engine may have a 50% longer life also there. So LPG has certain disadvantages. The ignition temperature will be somewhat higher than the petrol. Therefore, the running cost of LPG would lead to the 5% reduction of the valve life. LPG vehicle weight is increased due to the use of high pressure cylinders for storing the LPG. The good cooling system is quite necessary because LPG vaporizer uses engine coolant to provide the heat to convert the liquid LPG to gas. So you can this is LPG typical LPG propane fuel feed system of an automobile vehicles. So in the auto rickshaws as well as some of the cars, they are using LPG as a fuel. The LPG tank is fitted in the bottom of backside of the backside. So from the LPG cylinder, the gas is from the LPG cylinder. The gas is transferred to the fuel line. So from this fuel line, it is transferred to the converter. So here the converter, the LPG liquefied gas is liquefied. The liquefied is converted into gaseous fuel. So after that, it is LPG propane carburetor. So here the air as well as the propane or butane mixes, and then it enters into the engine cylinder for further combustion process. So these are next one is natural gases. So natural gases almost in 2008, 1998 itself in Delhi is much polluted. Because of that, the Supreme Court ordered all the vehicles in the Delhi to be converted into natural gas fitted vehicles. So because of that, the natural gas is this natural gas obtained from oil wells. Natural gas is a mixture component consisting of mainly of methane, 60 to 95%. Larger amount is methane, and the remaining is a smaller amount of C2H5, ethane. Okay, so it is stored as a compressed. It is stored as a compressed natural gas for a pressure ratio of 16 to 25 bar, and liquefied natural gas LNG for 70 to 210 bar at a temperature of minus 160 degrees C. So advantage of natural gas fuels, the octane number is around 110, which makes it very good SI engine fuels. Because of the high octane number and flame speed is higher, and the engine can operate with a higher compression ratios, low engine emissions, less aldehydes than methanol. So fuel is fairly abundant worldwide. It can be made from coal, but the process of making is very costly. Natural gas can be compressed, and then it is called as a compressed natural gas. CNG is used to run an automobile vehicle just like LPG. So CNG fuel system is similar to the LPG fuel feed system. CNG conversion kits that like a gas carburetor converter as well as are used for petrol-driven cars into CNG-driven cars. So this kit contains auxiliary parts like a converter, mixer, and other essential parts required for conversion. So this is the era of multiple fueling alternatives. So you can see that these are the various sources of energy. Energy is produced from natural gases, petroleum, and solar, biomass. These are the various sources of energy. And we have stations like conventional fuels for CNG fuel stations, gas stations is there, and then CNG stations and hydrogen station is also there. Hydrogen stations and EV, electric vehicles recharging from grid. So these are the various up to. So we covered the alternative fuels. Next we move on to the alternative vehicle technology. So in the alternative vehicle technology, we are going to discuss. I am going to discuss the electric vehicles and fuel cell vehicles. So electric vehicle, the development of electric vehicle charging infrastructure in India is growing steadily as the country pushes sustainable mobility solutions to aim to reduce the dependence on fossil fuels. Here, a breakthrough of the current state and effort being made to enhance the EV charging infrastructure is in India. So faster government initiatives and policies, we have faster adaptation and manufacturing of hybrid and electric vehicles. Indian government has launched FAM 1 and FAM 2 the schemes to promote electric mobility by providing incentives for electric vehicles and charging infrastructures. National Electric Mobility Mission Plan. This plan aims to promote electric vehicle adaptation and enhance charging infrastructures. And state level support is also there. Various state government has introduced their own EV policies with the incentives for the establishment of charging stations. So recently, our Tamil Nadu government is also started one of the EV car plant in Thoothukudi. Almost all the automobile sector, all the automobile companies are producing e-vehicle because of the stringent emission norms. All the automobile sectors are doing more research in this area of more research in these areas, and they are now slowly we are converting the conventional fuels to hybrid, then hybrid to fully electric. Slowly they are converting. There are charging networks, public charging stations, and public charging stations. India is working towards expanding the number of public EV charging stations across the cities, highways, major transport hubs, and private players like Tata Power, Photon, Ather agencies, and Exim and Reliance. So we are also investing on the building EV charging stations and highway chargings to support long distance EV travels. Charging stations also being set up along with the highways. This will help us EV friendly ecosystem for intercity travels. Then types of charging for electric vehicles: one is slow charging, another one is fast charging. So typically at homes, workplaces, this takes several hours for a full charge EV, but it is convenient for overnight charging. Slow charging and fast charging, these chargers are installed at public locations like malls, highways. So they can charge us EV 80% in around 30 to 60 minutes, depends upon the model. Challenges in EV infrastructure development: high initial cost, lack of standardizations, and grid readiness. So these are the major challenges we are facing. And technology and innovations, mobile charging stations, battery swapping. So battery swapping is one of the method for we can exchanging the battery. So old battery, when the battery is discharged, so we can go to the fuel stations and we can exchange the old battery. This is one of the technology, battery swapping technology. Then mobile charging solutions. Some of the companies are experimenting with the mobile charging units, which can go to the customer locations to provide chargers. And solar power charging. Some of the EV stations are integrated with the solar panels to provide clean energy for charging and making process more convenient. And this is a future plan: national network expansions and public-private partnerships. The government plans to install at least one charging stations for every 3 kilometers in the urban areas, along with the major highways by 2030, and collaborate between the private companies, state governments, and public entities, and expecting to accelerate the infrastructure development. These are the key players in charging infrastructure: Tata Power, Photon, Ather, and okay. So this is an electric vehicle overview of electric vehicles. You can see that this is a traction of batteries, traction battery track. So there is a battery pack, depends upon the travel distance. So based on the travel distance, how much kilometers we are. So with this travel distance, based on the travel distance only, the design number of battery packs. Okay, these are the charging port, and this is a transmission. Transmissions like clutch, gearboxes, other transmission road vehicle power transmission. These are the electric traction motors for electric traction motor, and this is a power electronic controller, and DC converter, and a thermal cooling system for battery management. And this is battery for this is a battery, auxiliary battery. This is an onboard charger. This one is an onboard charger. So when the battery is fully charged from the battery, it goes to the converter. Battery, we have a DC current. For charging, we are using when we are supplying from charging stations. This here battery requires a DC current only. So this DC, when we go to electric traction motor, so before that we have a converter. So this requires AC current. This requires AC current for driving the wheels. Okay. So whenever we are accelerating the pedal, the electronic control module gives directions to the gives proper directions to the control units, and then the vehicle will move. Whenever we accelerates, whenever decelerate, during that time the battery is charging. This is a regenerative braking system. So this is the infrastructure, charging infrastructure, EV charging infrastructures. These are from grid to the vehicle. How we are charging AC to DC converter like that. AC to DC converter, rectifiers, EMI filters, protection units. These are the vehicle to grid. We are charging station. So these are the key components for electric vehicles: battery, electric motors, then inverter, charging station, and then regenerative braking, power control unit, and then power control units plays a major role in the electric vehicles that manages the overall flow in the EV. It coordinates the battery, motor, and inverters, and to ensure the vehicle operates efficiently and respond to the driver inputs. So whenever the driver accelerate or decelerates, based on that it will respond. Then regenerative braking, already I told that EV uses a regenerative braking system which recovers energy that would otherwise be lost during the braking and feed it back to the battery. So battery is charging during that time. So vehicle control unit is the brain for the vehicle. It monitors and controls the various vehicle systems such as battery management, energy consumptions, and performance settings. It also communicates with the car user interface to give real-time information to the drivers. This is how an electric vehicle works. Already I told that the battery. Then from battery we have a DC power. So then we have inverter. That inverter converts the AC into DC, and then it moves the power supply to the electric motor that generates torque using electromagnetic inductions. This force is transferred to the wheels and propelling the vehicle forward or backward depending upon whether the vehicle is accelerating or reversing. Then we have regenerative braking. Then charging the battery. When the battery is run slow, the vehicle can be plugged into the external power sources. So this can be a standard outlet of level 1 charging or a dedicated charging stations level 2 or fast charging, DC fast charging. The charger sends electric power to the battery and the vehicle onboard chargers converts into correct voltage for charging. This system helps to optimize the energy consumptions during the vehicle runs smoothly and efficiently. So these are the advantages of electric vehicles. Some of the advantages of electric vehicles: environmental impact is zero tailpipe emissions. So there is no tailpipe in this electric vehicles. Instead of engines, we have engine is replaced by the motors, electric motors, brushless contact motors, zero tailpipe emissions, and cost efficiency. EVs are typically cheaper than unmaintained traditional vehicles since they have fewer moving parts, only lesser moving parts, and quite in operations and performance. Instant torque is possible and low maintenance. So these are the advantages of electric vehicles. And when we go for disadvantages, limited range. So we cannot. So at certain durations, the battery will discharge. So limited range travel and charging time. While charging times are improving, it still takes longer to charge an EV compared to the fill up on gasoline or diesel. So whenever when you fill gasoline or diesel, within 5 to 10 minutes we can fill the tank. But in EV, it takes larger time. And charging infrastructure, charging stations are still less widespread than the fuel stations. That is also one of the disadvantages. And battery life, well, battery are improving, they degrade over a time and may need to be replaced after several years, which may be also expensive. The battery pack is also very, very expensive. Battery storage, batteries, we have different types of batteries available. That is lithium-ion batteries. Currently, a dominating technology in the EVs. So these batteries are lightweight and have a high energy density and are widely used. However, they require mining of lithium and other metals, so which can be which can have the environmental impact. So future development, recycling programs and improvements in the battery materials such as solid state batteries are expected to reduce the environmental impact. Sodium ion batteries uses sodium instead of lithium. So this is more abundant and cheaper. These batteries would have a sustainable alternative in the long run. Then solid state batteries, these batteries replaces a liquid electrolyte with a solid electrolyte, improving safety, energy density and lifespan. So, this would offer higher energy density and faster charging time than the current lithium ion batteries. Then flow batteries uses two liquid electrolyte solutions stored externally in the larger tanks. So these batteries can store larger amount of energy and are particularly useful for grid scale energy storage. Then another one is supercapacitors. There's a supercapacitors can store energy. Supercapacitors can store energy for a shorter burst and are ideal for applications requiring rapid discharge. Thermal management. Then thermal management of batteries is a crucial aspects. For ensuring the safe, efficient, and long-lasting performance of battery systems, particularly in electric vehicles and other high-power applications like energy storage systems. Batteries, especially lithium-ion batteries, generates heat during charging as well as discharging cycles. So, if it is not properly managed, this heat can reduce the battery lifespan as well as performance and safety. So, why thermal management is important? To prevent overheating and enhances the performance and prolong battery life. So, for this reason, we have to go for thermal management of batteries. So, this is a digital core for cell voltage measurement, internal power supply module, man-machine interface, then general digital outputs, communications modules, pack voltage for current measurements, and temperature sensors. So these are the BMS, battery management system framework. So these are the battery production and recycling process. There is a component production of anode, cathode, dynamic materials, covers, and electrolyte and separators. So these components are produced. Then cell production, generation, and get together of a single cell. So a single cell is produced. Then module, to arrange the arrangement of cells into bigger modules and incorporate some electronic managements. Then pack assembly, installation of modules together with a framework that oversees control and charging temperatures. Then installation, then pack assembly, then vehicle integration of the battery pack into the vehicle structures. There's a bottom base of the vehicle. Then use aim indicates vehicle battery lifetime. Then reuse and recycling, battery reuse and reconstruction and cleaning preliminary for to reusing the materials and parts. This battery production and recycling process, and this techniques for battery thermal management. So this active thermal managements. There is liquid cooling, air cooling, or phase change material is used to safeguard the batteries. So the battery temperature to be maintained below 80 degrees C. So liquid cooling is one of the most effective method for controlling the temperature in the high performance batteries pack. Coolant circulates through the tubes or channels in direct contact with the battery cells and absorbing heat and carrying it away. So liquid cooling is highly efficient and it's often used for EV and large scale storage systems. So that's air cooling and phase change materials also used for active thermal managements. And passive thermal managements, thermal insulations, heat sinks, and reflective surfaces. So passive thermal management rely on the active components like fans, pumps, but instead of use of heat absorbing materials and natural process of heat dissipation. So battery thermal management in electric vehicles, EVs rely on efficient thermal management systems to ensure battery temperature and stays in the optimum operating range, and the battery directly impact the vehicle performance, driving range, and charging system. These are the advanced materials for thermal management: graphite and graphene phase change materials. And these are the sensors we have to use and battery management systems. Then future trends in thermal management: AI and machine learning, solid state batteries, and advanced phase change materials. So these are the challenges in thermal management: cost, weight and space constraints, efficiency. These are the constraints. This now next, green hydrogen production. So green hydrogen productions, there's fuel cell vehicles. Green hydrogen production refers to the hydrogen that is produced using renewable energy sources. The key differentiator being that it avoids the carbon emissions associated with the traditional hydrogen production methods. So there is electrolysis of water, then renewable energy sources. With the help of electrolysis of water, we can get hydrogen. With the help of get hydrogen. So this process is clean, and if the electricity use comes from the non-fossil fuels, it comes from non-fossil fuels. That is hydrogen and oxygens. Water is split into hydrogen as well as oxygen in this method. Renewable energy sources, the electricity for electrolysis comes from the renewable energies to ensure hydrogen production process remains carbon free. Wind, solar, and hydroelectric energies are the most popular choices. Then zero carbon emissions. The production of green hydrogen produces zero carbon emissions and making it key part in the energy transition and decarbonization effort, especially in the sectors like heavy industries and transportations and energy storages. So next one is proton exchange membrane fuel cells. So proton exchange membrane fuel cell is a type of fuel cell that converts chemical energy from hydrogen into electrical energy through electrochemical reactions. So this is one of the most commonly used fuel cell type, especially in the applications like electric vehicles and portable power devices, due to its high efficiency and lower operating temperatures and relatively simple designs. So this is a proton exchange membrane fuel cells. So you can see that this is anode, and this is cathode. We have an electrolyzer as well as electrolyte. Electrolyzer is placed in between here. Electrolyzer is placed. So you can see that in the anode side we are supplying hydrogen. This hydrogen is converted into H plus E electron release ஆகுது. So this H plus can travel, and electron is flowing through the circuits, and the oxygens cathode side we are anode side we are hydrogen gas is supplied and split into proton plus electron converted. That is converted to proton plus electron converted. So this cathode side we are oxygen is supplied and combines with the protons and electrons form a water. So the proton exchange membranes allows the proton to pass through the anode to cathode and blocks electrons, so which may travel through the external circuits. The catalyst we are using is platinum to facilitate splitting hydrogen molecules into proton and neutron. So this is a catalyst used for splitting the hydrogen. This is a working principle. There is anode, this hydrogen is introduced, and cathode where oxygen is introduced. And electrolyte, there's a proton exchange membrane. It's a solid polymer membrane that conducts proton. That is a hydrogen ion H plus, and not electron. This is the proton exchange part of the fuel cells, and the catalyst layer usually made up of platinum or other precious material that helps splitting the hydrogen molecules and facilitate the electrochemical reactions. So these are the fuel cell vehicles. This is a hydrogen storage tank with this high pressure safety valves, and this is a refilling valves. There's a check valves. Check valves allows fuel only in one direction only, and this is the main cutoff valve. From this the high pressure hydrogen goes to the fuel cells. High pressure is converted to low pressure by using medium pressure. That is converted to medium pressure, and we have pressure regulators is there. So with the help of these pressure regulators, we can convert this pressure of hydrogens, and then we can supply to the anode side. We can supply to the anode side hydrogens, and cathode side already oxygen is there. So from that we can get a current. The electron as well as electrons that's flowing in the circuits that passes through the circuits, and because of that we are getting electricity. This from this electricity goes to the DC motor for to drive the wheels to power the transmission systems. So here you can see that this hydrogen storage cylinders, this is fuel cells. Hydrogen storage cylinders to the hydrogen goes to the fuel cells. So here the reaction is taking place, and the final reactions we are getting hydrogen as a exhaust, H2O as a. So we are getting H2O as a exhaust, and there is no tailpipe emissions. And this is the electric motor to drive the wheels. This is onboard hydrogen fuel system for the fuel cell vehicles. So these are the advantages of proton exchange membrane fuel cells: high efficiency, low operating temperatures, and clean energy and fast startup time. And these are the applications we are using for electric vehicle and backup power and portable electronics. So this is a future transportation with a smart grid and sustainable energies. So almost you can see in these pictures all the renewable energies are interconnected with the grid for smart city development. Okay. The complexity of future global sustainable energy system intelligently interlinking a multiple decentralization of clean energy sources with efficient stationary users and electric vehicles with the millions of buffer batteries. So you can see that this is a wave energy, and this is geothermal, and this is ozone thermal energies. All the energies are converted into a grid, and we have electric cars, photovoltaic power, solar power we are getting, and also we are having a solar thermal power, and this is a solar roof, air guns, solar roof. So all the renewable energies are integrated here to get a clean and clean green energy for clean energy eternity. This is service benefits of vehicle to grid technology. So we are getting grid stabilizations there, and infrastructure benefits, and with the help of DR programs, whenever DR program environmental impacts, we have reduced emissions, and we are using the renewable energies. So we are using the renewable energies, and that is connected to the grid stabilizations, and then infrastructure benefits as well as DR program. So these are the service and benefits of vehicle to grid technologies. And these are the vehicle to these are the benefits primarily revolve around the sustainability of and futuristic advancement. Adopting vehicle to grid technology brings numerous benefits such as integrating renewable energies, grid stabilization, demand responses.
Speaker is available. Now you can ask any question. Questions from chat box. Hello, Karpasamy sir, able to hear me?
Yes, sir.
One question from chat box. Mr. Ilongovan sir, for hydrogen fuel cell cars, do we need to provide pure oxygen from oxygen cylinder, or will the fuel cell take atmosphere? This is a question, sir. Speaker, sir.
Yes, sir. The oxygen is getting from the atmosphere only.
Okay. Take air from atmosphere only. It's the lengthy questions. Electric vehicles are economically friendly, not adding CO2 or other greenhouse gases to atmosphere. However, this is fully true only when the electric power to charge the battery come from renewable energy sources. Otherwise, the electric vehicles are as bad as other conventional vehicle, because conventional power plant has to produce that amount of extra power to charge the electric vehicle. Conventional power plants are emitting greenhouse gases to atmosphere. Am I correct? Like that he is asking, sir.
Yes. Conventional, if you use conventional power plant, the greenhouse gases also increases.
Yes, sir. Yes.
But we have converted into renewable energies only. Then only we have to do multiple of our output multiple times only. When we get it, only we can get less amount of CO2.
Dear participants, any other questions? Dear participants, is a time for a question session.
type of electrolyte. That is platinum, sir. What type of electrolyte used in the
Fuel cell, yeah. What type of electrolyte used for fuel cell, sir? If there is no questions, I put forward my vote of thanks to speaker first session. I would like to take a moment to express our heartfelt gratitude to our distinguished speaker who shared their valuable insight on transportation energy for sustainable future. Sir, your expertise and knowledge have enlightened us on the latest development and innovation transportation energy, and we are grateful for the time and effort you took to prepare and deliver your presentation. Sir, your discussion on the importance of sustainable transportation, alternate energy sources, and cutting-edge technologies have inspired us to think critically about the future of transportation and its impact on the environment. We appreciate your emphasis on the need for collaboration, innovation, and policy support to drive the transition towards a more sustainable transportation sector. Dear participants, please join us in thanking our esteemed speaker for their enlightening presentation. Thank you, sir. Once again, Dr. Sang, sir.
Thank you, sir. Thank you very much. Thank you.
Yes, sir.
Thank you very much to all.
Yes, sir.